if it was open to their banking website, they'd just go, change. And then people would argue with us about it cheating, and not my fault. Oh man, all kinds of crazy. We had a mistake one year where we, in all classic fashion, left the login to a box as root, which is embarrassing for multiple reasons. A, because we left the box as root. Secondly, because nobody found it for like an hour, which is just sad. And then when somebody did find it, they didn't patch the box up, so somebody else took it from them. And then we finally figured out we did, and we reset the computer, and we had it all back. But they decided they would be crafty, so when they gave us the box back, since we didn't want to reset it, they left a nice little cron job that would look for every it would look for the string that we tagged all of our flags with in every file on the computer and change it to their team name. The problem is their cron job didn't check to see which type of files it was modifying, so at some point it started going through like libraries in the computer, like glibc, and just screwing crap up. So about 20 minutes into them scoring, the box just dies, and they start screaming at us, "What did you do?" And we're like, "It's not my fault, you're a bad admin." I didn't do it. Anyway, it's hard as it is to talk about my own service, because my favorite services are stuff everybody else wrote, because they're really cool. One of my fun little gems that I wrote was called Global Thermonuclear War. I hope at least one person in this room has seen war games and gets the joke. Thank you. So Global Thermonuclear War was this webpage that you would go visit, and there would be a little password field, and there would be a button, and the button would say download Unlocker, because that's not ominous at all. So you download this Unlocker, and there was a binary in it, and obviously it was full of horrible, nasty acid venom things that were designed to do horrible things to your computer. And I hoped people would run this in VM, because at one level, it did bad things. Okay, so what this binary was a 3-card Monty. You'd run it, and you'd see 3 options. And you could, play chess, you could play tic-tac-toe, or you could play Global Thermonuclear War. If you played tic-tac-toe, I actually wrote a really crappy terminal version of tic-tac-toe that you could play and win. And eventually, if you did win, it would display a ROT13 encoded message at the bottom of the screen that would mutate every 3 times that you ran it. And if you decoded all of them and put them together in a giant string, excuse me, it would just tell you, this is a red herring, why are you looking here? And a lot of people spent time on that. I really don't know why they did. It's ROT13. It's not hard. And some people actually decoded it and then thought there was something else in it instead of looking at it for hours. I didn't know I could program that good. Apparently I could hide things in plain text. The chess game was just literally a link to a Windows chess game that people downloaded, and eventually people rooted that site and did all kinds of horrible things to that company. I don't even know who it was. I just picked it at random. It was the first link on Google when I looked up chess. So, sorry for them. And if you hit Global Thermonuclear War, it would show you another 3 options. And those 3 options would say, okay, you're playing Global Thermonuclear War, which set of cities would you like to attack first? And I actually took the orders from the movie, so Seattle was in there, and you could decide if you were going to be the Russians or the Americans, and you pick one. And each of these was the game itself. There were 3 options. One option would echo the correct password to /devnull, which is about as close as you were going to get to having it give you the answer. And the other 2 options would initiate malware payload. One of the malware payloads would overwrite the first 512 bytes of every device attached to your computer with a really nasty bootloader that would just say in giant ASCII art letters and a giant middle finger, the only winning move is not to play. And if you modified that firmware, then you got another firmware because it detected the fact that the binary is modified, and it just said har har, and kind of laughed at you. And the other payload would restart your computer. So you have this binary, and you run it, and if you're not S-tracing it, it just exits if you get it right. So what are you going to do? You're going to run it again. So you were very, very likely to try to run it against both horrible payloads, and it would hurt your machine. And I hoped people would run it in the VM, and most people did. And I know at least one kid didn't, because it was his first DefCon, and I had this conversation with this 16-year-old kid who was crying in a corner because his box was nuked. And I tried to explain to him that, it's only the first 512 bytes of your hard drive, man. You could just restore it. And he was like, but I just formatted it because I thought it was screwed. So I'm a horrible person. And again, with the wacky antics, so the coolest thing about that service, I think, was how the guys who beat it ended up beating it. We had 2 teams from Korea that year? Vand and DDEC, right? Yeah. So the binary, the way that it was created was, the only obfuscation in it is the key was a really stupid series of times tables. And rather than try to out-binary foo people that were trying to reverse it, I think I packed it too or did something stupid. Every time that you downloaded it, it was dynamically compiled. I actually had web script that would look through the source code of the file, change the statically encoded key in the C source, compile it just for you, and then send it to you. So every time that you looked at it, it was totally different. The key was totally random. There wasn't a way to read the algorithm out of the binary because it didn't exist. So the guys who ended up just really reaming the hell out of that service figured this out. And they wrote a Python interpreter to read and unpack the binary and suck the key out of memory when it would run, and then dynamically score the game every minute, which is just fucking awesome. I asked them for the script, they still haven't sent it to me. So if you guys see this, I want that script. It's pretty cool. But yeah, that was one of my favorites.
All right, now I'm gonna do Happy Dance last, guys, because I'm probably gonna get some stuff thrown at me.
Awesome service.
Let's see.
Quota.
That's the one I'm trying to think of. Which one was Quota?
The movie slide.
Oh, movie quotes. All right, cool. So anyone? So people who played last year. All right. Do you guys remember the one with the animated GIFs? Oh, I love you too. So this was kind of an interesting service, and I always pride myself when writing openCTF services to just kind of go completely out the window with it and just go for something crazy. This time around, it was animated GIFs from movies. Oh, that's no big deal, right? So you go to a webpage, you see an animated GIF from a random scene of a random movie, and there's a text box. I don't remember what it said, but read my lips. And that was it. If you were able to insert the text dialogue of that scene in the movie, you would score. So let's say you see Neo watching Morpheus jump across the buildings, and he's, whoa. If you were to respond with, whoa, you would score. And literally what it was is I wrote a series of M-player scripts and M-encoder scripts that would take entire movie files, convert them to RAW because of the frame-seeking behavior. So I filled up my terabyte drive like in an hour. I'm like, holy shit. Movies convert to RAW. Then I would take these subtitle SRT files, which I had a Python script parse out all the timestamps from the Python file or from the SRT file, and then M-encode those few seconds from each video. So I ended up with something like 30,000 animated GIFs. So if anyone wants the entire movie, like The Matrix or Gone with the Wind or Passion of the Christ in animated GIF format, I have that. And it was pretty fun. Yeah, I know. So there was this random Russian Alice in Wonderland animated cartoon. And I heard about this. And I couldn't find it anywhere. And I searched and searched and searched the intertubes to find this thing, because I figured this would be fantastic. No one's ever going to find this. And I finally find it in a hole-in-the-wall forum. And it was posted on RapidShare. So I download off RapidShare. I check it out. It is bizarre. It's just creepy, and it's got subtitles. So now that I have this file, I proceeded to contact RapidShare as a copyright holder and had them take it down. So maybe it existed somewhere else, but probably not over the 2 days of DefCon. And Quota was a lot of fun. I hope you guys had fun with that. I guess one of the things you had to do to beat that would be did anyone actually script a response? Or did you just watch the movie and like pull out the subtitle file, like, oh, I think he said this? No one actually scripted? Awesome. I figured the best way to do it in a scripted fashion would be to do some sort of frame-seeking behavior and look at the different frames of the GIF and then seek through the video file and look for the same files or same frames. But I don't fucking know how to do that. So, ToCR?
Yeah.
ToCR. Which one was that?
The
OCR?
Q, the quick Q.
All right. So, did anyone play 2 years ago when there was like the custom alphabet written in div tags? No. I don't know how to describe it better than that. Give me a break here.
The flashing code.
Oh, yeah. So you go to a page and you see a word or a sentence, and I think it got longer with time. And it basically was a custom alphabet that I wrote, in JavaScript with Ajax, so I could draw on my screen and create an entire alphabet and then print it back to you. It was basically an OCR challenge, but the characters had, different sizes and backwards and Quake logo for the Q, a few other weird things. But what's great about it was the best way to do this logically would be to look at the source code and figure out what the characters are, where they're coming from. The problem is the alphabets are drawn onto the screen using floating div tags in a random order. God bless you. So this, I suppose you could extrapolate the points and write something that would put it all together and figure it out, but again, I don't know how to do that. Grid of death. So, to even get to the source code, if you tried to look at the source code, it used a series of client-side obfuscation techniques that I developed for a previous talk on hacking with Firefox and using Firefox as a scraping platform. It had Flash one-time padding, Flash encryption, which just hooked into the what's that called? JavaScript? No, the hook function.
No.
JavaScripts. And that one was all right. Enjoyed it. Do I have to do them all at once? Can you spread them out a little bit, guys?
Put the pictures up on mine.
I'll do that.
There you go.
So did anybody play 3 years ago who played an audio service called Banshee? You remember that? Anybody listen to the wacky portal sound? Yeah. So nobody got it. The person who came closest. No. Oh right, somebody did get.
Radio, no one's off Cake Radio. They got Banshee, I think. But
I don't remember. I don't think anybody solved it. So Banshee was an internet. Well, okay, it was a WAV file. You download this WAV file, and it was the Portal song. It was cool, and it was really staticky. And if you listen to it, the static would only appear at certain intervals in the song. It would be constant throughout the song, but the intervals between each tick in the static were deliberate, because the static was an MP3 file in the WAV file. And if you took all of the data of all of the static out of the file, which you should have been able to do because the distances between the ticks were the same. It was at exactly 44,001 kilohertz. So every one it would count. And it was this big binary blob. And the first chunk of it was an MP3 file, and the second chunk of it was the first half of a one-time pad. The second half of that one-time pad was read to you by a computer in that MP3 file. So you'd have to listen to it and type it. This was supposed to be really simple at first because it only used 4 characters. The idea was you'd be able to type these 4 characters and store them together and have the answer. And every time that somebody scored, the code that created the WAV file would recalculate everything that I just explained. So the idea is that the message would get longer. So the longest message that it would ever use is the Microsoft SAM voice reading the entire Hacker's Manifesto backwards. And you'd have to type all that, and then it would compute. But I don't think anybody ever got it. So if anybody's curious as to how it worked, that's how it worked.
You do Maze? All right, let's try to get the pictures up.
Yeah.
Pictures up?
Can
Can you put the pictures up?
Laptop on the
Put
screen
CB's
here?
laptop on?